Hey everybody, in today's video we are going to dive into reflections, which if you remember are a specific kind of transformation. So in a reflection, we've talked about this before if you've watched any of our other videos, a reflection flips a shape over a line to face the opposite direction. And you can sometimes just call it a flip, or you might hear other people just call it a flip. Okay? Give an example of a reflection in real life. So think about this for just a second. What is an example of something in real life that reflects? I think a really common example that our students usually think of is a mirror. And then sometimes we have people who get really fancy and really sciencey, and they'll talk about how light can reflect off of shiny surfaces. Um, that's kind of a cool example of a reflection that's a little more sciencey. So let's look at what happens when we do a really exact reflection in math. So in math, in this level of math, we really only reflect two different ways. We can reflect over the x-axis or we can reflect over the y-axis. When you get to high school geometry, there will be other kinds of reflections, but this is all that we're going to do for now. So if you look, we've got this little bird. I'm going to outline the original here in purple. And if we wanted to reflect him over the x-axis, that means that bird would flip and become upside down over the x-axis. Versus if we wanted to reflect that bird over the y-axis, now that bird is just facing the opposite direction. Instead of looking to the right, he's looking to the left. Okay, and we'll do way less complicated examples than a bird. We're not going to have to draw pictures like that, but that's just kind of what it looks like. Right underneath that, there's some more vocabulary that you got to know. Okay, and this is a more practical example. It's just a triangle, and that is something that you will see reflected in math frequently. So this is triangle RAV. And then if we reflect it like this, it's the same triangle, but it's been flipped to face the opposite direction. And you'll notice that these letters look a little bit different because they have an apostrophe after them. So after you reflect a figure or after you do any kind of transformation to a shape, you have to label it a little bit differently. So originally it was triangle RAV. Now the name looks like this. The question is, how do you say that? So those little apostrophes, we say the word prime. So this is R prime, A prime, V prime. Okay, just to show which one was the original and which one was after the reflection. All right, let's go look at two mathy examples. So for each of these, we're going to be given a shape. This one is a trapezoid. The next one is going to be a triangle. And we're going to do three things. We're going to write the coordinates of the pre-image, which is the original shape. It's that green one that you see right there. Then we're going to reflect it, in this case over the y-axis. Then we're going to write the coordinates of the new image or of the image. So I'm going to pause this video for a second and write down these new coordinates instead of going through it with you step by step. So there's the coordinates. If you still need help with plotting points, we have a video for that. And if I remember, I'll link it in the video description, but you can always go back and watch that. So we have the coordinates of the pre-image, that green trapezoid. Then what we're going to do is we're going to reflect it. So I'm going to grab a highlighter. And since it says to reflect across the y-axis, I'm going to highlight that y-axis. And then the way that you reflect to make sure that you do it perfectly is you count how many spaces each point is from that highlighted axis. So point L is 1, 2, 3, 4 blocks from that highlighted axis, which means its reflection is going to be 4 blocks on the other side. And I'm not going to draw the little jumps because I don't want things to get too confusing. I'm just going to count and maybe you'll be able to see my pen. I'm going to go 1, 2, 3, 4 spaces. And that is where the new point lives, and that is called L prime. And then I'm going to do the exact same thing with the 3 other points. So M is 1, 2 spaces from the highlighted axis. So its reflection is going to be 1, 2 spaces from the highlighted axis, and that is M prime. Now, I would say you don't need to draw those jumps because it's probably going to make your paper confusing. But for the first time of you seeing this, I want to draw them so that you can see what I'm doing. Okay. N is 1, 2 spaces from the highlighted axis. So we're going to go 1, 2 spaces. And that's where N prime will go. And then we just have point P to do. 1, 2, 3, 4 spaces. So we'll count 1, 2, 3, 4. And that is where P prime will live. Now, we always tell our students, do not connect the points because your paper is going to get messy and most people don't draw super straight lines. I'm going to connect them for just a minute with a light color so that hopefully you can see this is the same shape. It's just facing backwards. And mine is not turning out perfect. So we certainly don't want you doing it on your paper and making a mess either. But hopefully you can see how that orangish color is a flip of that green one. So I'm going to erase those. And then I'm going to write down the new coordinates in this table. And I'll be right back. All right, so I have written down the new coordinates for the reflected trapezoid. If you are really keen at noticing detail, you might notice that the new coordinates look really similar to the original coordinates. We don't usually teach our students how to do reflections just by looking at the coordinates, but if you happen to notice that the original point, -4, 3, only changed slightly and it became +4, 3. So when we went over the when we went over the y-axis, all of the x's changed their sign. That's not how we teach it in class. We always just draw out the reflections. But if that's something you are already noticing, good for you. Let's do one more. And here we have this triangle. So the first step is going to be to write out those coordinates. So again, I'm going to pause and write those out. And then this time we're reflecting over the x-axis. So I'm going to highlight the x-axis so that I don't mess up. All right, and then I'm going to count how far is each point from the x-axis. And I'm going to start with W because W is listed first, and I think W is the hardest one on here because W is right there. It's already on the x-axis. So it's 0 spaces from the highlighted axis, which means its reflection is going to be 0 spaces from the highlighted axis. So that, where I just did that purple point, that's going to be W prime. It doesn't go anywhere. All right, then I'll do point S, which is 1, 2, 3, 4 spaces from the x-axis. So its reflection will be 1, 2, 3, 4 spaces from the x-axis. And then for P, it's 1, 2, 3, 4 spaces from the x. So its reflection will be 1, 2, 3, 4 spaces from the x-axis. And then I'm going to grab that light color again and I'll show you what it would look like if you connected your points. So hopefully you can tell that that lighter triangle is a reflection of the green one, right? It's upside down. It flipped over the x-axis. We do not suggest connecting your points, so I'm going to get rid of those. I'm going to write down our new coordinates and I'll be right back. All right, there's my coordinates. And the way that test questions and worksheet questions and everything work is you could see questions where they ask you to graph the new shape or where they ask you to give you the new coordinates or ask you to give them the new coordinates. So making sure you can do both is really important. And hopefully I remember to link that video about plotting points. But that is it for how to do reflections. See y'all next time.